Hello students, in the previous videos we had a discussion about these weighted aggregative index numbers, Laspey's price index, Paget's price index, Marshall-Edgeworth's price index, Dorbish-Bowley's price index. In this class we shall discuss the last two weighted aggregative index numbers. They are Fisher's price index and Cayley's price index, which is also known as fixed weight index. Then what is Fisher's price index? This Fisher's price index is the geometric mean of Laspey's and Paget's index number. For this, you have to recall your geometric mean formula which you had studied in your high school or you have studied in your first PUC also. Just look at the first part of this formula P01F, that is price index numbers of Fishers, F indicates Fishers, that is equal to square root of Laspey's price index into Paget's price index. So this is just like your geometric mean formula. G is equal to root AB, where A is Laspey's price index and B is Paget's price index. Then this Fisher, he is a statistician. Fishers examined many formula in order to construct this Fisher's price index, and finally he derived this formula. This formula is actually square root of summation P1 Q naught divided by summation P naught Q naught into summation P1 Q1 divided by summation P naught Q1 into 100. You can just compare the first part of this formula is actually a Laspey's index number and the second part is actually Paget's index number, and that is multiplied by 100. So this is Fisher's price index. Then the speciality of this Fisher's index number is it is ideal index number, that is out of all the index numbers that you have studied, this is the ideal one. There are many reasons for it, and they are: firstly, it is based on the geometric mean. While explaining the characteristic of index numbers, I told you that index numbers are actually ratios which are expressed as percentage. Generally, for the ratios, geometric mean is the best measure. So since these index numbers are ratios and Fisher's index number is a geometric mean of Laspey's and Paget's, it is best measure, so it is an ideal measure. Then in the case of Fisher's index, we'll study we have taken both base year quantities and current year quantities, that is both Q1 and Q0 are considered. Then this index number satisfies both time reversal test and factor reversal test. So these time reversal test and factor reversal test are actually the test used in order to check the accuracy or the correctness of the ideal numbers, index numbers. You will be studying about these tests in further classes. Then lastly, it is free from bias. So these are the four reasons why we call Fisher's index numbers as an ideal index number. So it is based on geometric mean, it considers both current year and base year quantity, then it satisfies time reversal test and factor reversal test, and lastly it is free from bias. Next and the last price index is Cayley's price index, or it is also known as fixed weight index. So why we call this as a fixed weight index? Because in case of this Cayley's price index, we don't consider simply the quantity of current year or quantity of base year. Instead, we will select a fixed weight. which represents both current year and base year. So that is why the formula is known as fixed weight index. You can see the formula here. P01K, that is Cayley's price index, is equal to summation P1Q divided by summation P0Q into 100. Here Q is the fixed weight. You can see Q, they have not mentioned 0 or 1, that is, they have not mentioned whether it belongs to current year or base year. It is actually a fixed weight, that is why there is just Q. Okay, so this is the formula of Cayley's price index. Now we shall solve the problems on both Fisher's index and also Cayley's price index or fixed weight index. Okay, so now we shall solve the problem. Compute Fisher's price index for the following data. They have given 5 items, then they have given price and quantities of 1995, which is base year, then they have given price and quantities of current year, which is 2000. Then just look at the formula of Fisher's index, that is P01F is equal to summation P1Q0 divided by summation P0Q0 into summation P1Q1 divided by summation P0Q1 into 100. So as usual, we need all these values, that is summation P1 Q0 and so on. Now since we have already done with the 4 price index, you know how to solve all these values. So can you just try all these values solution? Yes. So we need P1 Q0, P0 Q0, P1 Q1 and P0 Q1. What is P1? Price of 2000. Q0, quantity of 1995. P0 is a price of 1995. Then Q0 is quantity of 1995. Then Q1 is quantity of 2000. Then for P1 Q0, you need to multiply this column with the corresponding value of this. That is 10 into 50, 500. Then 100 into 2, that is 200. 60 into 6, 360. Then 30 into 12 is also 360, and 40 into 12, 480. Then what is the total of this column? 1900. Please note down these values in order to substitute in the formula. Then P0 Q0 is corresponding multiplication of these two columns, that is 6 into 50, 300, then 2 into 100, 200, then 4 into 60, 240, then 10 into 30 is 300. The last one, 8 into 40 is 320. Then what is the total of these values? 1360, that is 1360. Then P1 Q1 is a corresponding multiplication of these two columns. 10 into 56, 560. Then 2 into 120, 240. 6 into 60 is 360. Then 12 into 24 is how much? 288. Then 12 into 36 is 432. Then total of this column is 1880, that is 1880. Then last column is P0 Q1, that is corresponding multiplication of this and this column. 6 into 56 is 336. Then 2 into 120 is 240. Then 4 into 60 is 240. Then 10 into 24 is 240, and 8 into 36 is 288. Then what is the total of this column? 1344, that is 1344. Now we need to substitute all these values in the Fisher's index formula. What is summation P1 Q naught? It is 1900. Then what is summation P naught Q naught? It is 1360. Then what is summation P1 Q1? It is 1880. And what is summation P0 Q1? That is 1344 into 100. Now in the next step you have to divide them. That is 1900 divided by 1360. It is 1.3971 into how much? 1880 divided by 1344, which is 1.3988 into 100. Here what you have to do is you need to multiply these two values and then take a square root, and then you need to multiply by 100. I repeat, first you multiply these two which is inside the square root, and then take a square root of that value, and at last you multiply by 100. So in the next step what you have to do is you just multiply these two value, 1.3971 into 1.3988. Just do it when I am saying multiply 1.3971 into 1.3988. So you will get 1.9543. Then take a square root of that using your calculator. Take a square root of 1.9543. So how much you will get? You will get 1.398. Okay, you will get many values. I have rounded off to 3 digits after decimal point. Did you understand this step? I will repeat for your clarification. Just multiply 1.3971 into 1.3988. You will get a value, right, which is 1.9543. Then take a square root of that value. You will get 1.398. You will get 1.3979 or so. I have rounded off and stopped at 3 digits after decimal point into 100. Then in the next step just multiply this to 100. How much you will get? 1.398 into 100 is 139.8. So this is an answer. Now how to comment? There is an increase by 39.8% in the price in current year as compared to that of the current year. Okay, I hope you are clear about the calculation of Fisher's index. Okay, now we shall solve problems on Cayley's price index or fixed weight index. Calculate price index number from the following data. So here they have not mentioned about which method to be used. Now how to identify that we have to use Cayley's price only? For that you have to see the quantities. Here number of units sold, they are nothing but quantities only. And have they mentioned whether this quantity is of base year or current year? No, they have not mentioned. They have simply mentioned number of units sold. They have not mentioned about year. Therefore, it is a fixed weight, which I have denoted it as Q. Then they have given price of both base year, which is P naught. Then they have given price of current year, which is P1. Now look at the formula of Cayley's price index. It is summation P1Q divided by summation P0Q into 100. So here what you need to do, you need to multiply P1 with the corresponding Q column value. Then you also need P0 multiplied to the corresponding value of this Q. Okay, you need a total of them. So now you need to make two more extra columns other than the problem, that is P0Q and P1Q. In P0Q, multiply base year price with the corresponding quantities, that is 25 into 22, 60 into 40 and so on. So first, what is 25 into 22, which is 550. Then 60 into 40 is 2400. Then 100 into 35 is 3500. And lastly 70 into 45 is 3150. Then what is the total of these values? 9600. Just add these values: 550, 2400, 3500, 3150. Then P1Q. P1Q is multiply P1 with the corresponding Q, that is 22 into 30 is 660. Then 75 into 40 is 3000. Then 110 into 35. 110 into 35 is 3850. Then lastly 90 into 45, which is 4050. Then take a total of these values, that is 660, 3000, 3850 and 4050 is 11560. Then substitute these values in Cayley's formula. Firstly, you need summation P1Q, that is P1Q's total. How much? 11,560. Then you need summation P0Q, that is the total of this P0Q column, which is 9600. Now in the next step, you just divide these two values and multiply by 100, that is 11,560 divided by 9600 into 100. I repeat, 11,560 divided by 9600 into 100. How much you will get? Did you calculate? You will get 120.417 or so on. We can round it off to 120.42. Now how to comment for this answer? There is an increase by 20.42% in the price in current year as compared to base year. I hope you have understood the calculation of both Fisher's as well as Cayley's. Thank you.